My name is Kurt from Microsoft, and I just want to introduce Chris Brown from Nutanix. Nutanix are one of our gold sponsorship partners at Ignite this year. And Chris is going to take you through some nice innovative stuff today. And then please make sure to go visit their stand at the expo during the day. So without much further ado, I'll hand over to Chris. Thank you.
Thank you. Yep. So as you said, my name is Chris Brown. I'm a solution technical manager at Nutanix, where one of my areas that I cover is cloud and Microsoft technologies. So that's what I'm going to be talking about today. Just a forewarning, because it is a vendor session, I unfortunately start with some marketing slides. I know that's not interesting, and I'm sorry. But after that, we will get into some juicy technical bits. We're going to talk a little bit about configuration, best practices, and designs for SQL, for Azure Pack, and for Exchange. And then talk about some of the backup solutions that we have. But once again, because it's a vendor session, I got to get that marketing in there. As you all know, because you're at Microsoft conference, and we've been hearing about Azure all week long, the cloud era is underway. Everyone's throwing into the cloud. Everyone's expecting the cloud for when they're using their infrastructure today. But what that really means is that people are expecting very fast time to market. If you look at a traditional infrastructure, it can take months to plan, deploy, implement, and install a gear, it's very, very different from the ability to go into a portal and click, I want a VM now. A very different experience. People want to be able to pay for only what they use and no more. Over-provisioning is very expensive and not what you do with the cloud at all. And so people are expecting that with whatever infrastructure they're choosing. And then one-click simplicity. You don't want to have to spend a lot of time planning these upgrades out. It took you 8 months to install and implement a traditional storage array, for example, and then it's going to take you another 6 months every time you need to plan an upgrade because there's so many different moving pieces. So that doesn't really fit with what people are expecting today. And then finally, continuous innovation. If you look at what the cloud's doing, you log in one morning and all of a sudden your virtual machines or your applications have new features, new power, new performance, and they didn't go down. They didn't have anything change on them. You just log in, new things are happening. And that's what infrastructure needs to provide today. The goal, really Nutanix's goal, is to provide these same things that people expect from the cloud on-prem so that you don't have to go to the cloud to get these benefits. So I'm going to blow through this slide pretty quickly, but it's basically the same points again, along with the ability to do enterprise-level things that, if you look at clouds, they're perfect for cloud-native apps. In many cases, that's where these applications were born. However, if you look at traditional infrastructure or traditional business apps, there's some things that might be missing. For example, tailored SLAs. You and only you can define how important a particular application is to your business. And sometimes with the cloud, you lose that. So we want to be able to give that control back. So what the hell am I actually talking about here? What are we actually delivering? So if you look at a traditional infrastructure, there's a lot of complexity. You've got on the top your cloud interface, be it OpenStack, be it vRealize automations, or be it Azure Pack. You've got options depending on what your infrastructure is. Underneath that, you've got your virtualization layer, and then your compute, storage networks, storage, and network. All different layers, all potentially from different vendors that all need to be intercompatible. So it really, at the end of the day, if you look at this, you have, depending on the size of the organization, three or more different teams managing the infrastructure, which makes it take a really, really long time to get anything through, to get new things added, to get things upgraded. So what Nutanix does is that we take all of those different pieces and we reduce it down to a single block. Rather than having a traditional storage and traditional storage area network and all of the different pieces moving together, Nutanix takes all of that and puts the storage back in the servers. So we call it an integrated scale-out compute and storage, or hyperconverged. This is where we started. On top of this, you run your virtualization layer, such as Hyper-V. And then on top of that, you can run your applications or your cloud interface. So that's hyperconverged in a nutshell. And at this point, if I'd been giving this presentation 2 years ago, people might not have heard of hyperconverged. But at this point, more and more people are familiar with it. So that's what we started with. From there, we're moving on. hyperconverged isn't all we do. We don't call ourselves a hyperconverged company anymore. We call ourselves an enterprise cloud company. The idea here is that we're able to provide all of the different services required to provide a cloud, such as self-service, file and block and container services, storage for all of your different devices, along with things such as automation and application ecosystem. Now, not all of these pieces are in place now, but that's where we're going. So, the reason I wanted to show this slide is just to show that, hyperconverged is great, and it's a huge step forward compared to traditional infrastructures, but we're going so much farther beyond that. Just to level set here to show kind of what a Nutanix installation looks like, is that if you see here, we've got x86 servers on the bottom. These can be Supermicro, which is what we sell, or Dell or Lenovo servers, or Cisco servers. Your choice, because at the end of the day, it's just hardware. Whatever one works best for you and your needs. On top of that, you run your choice of hypervisor. So Hyper-V, because we're at Microsoft conference, is what I'll say. And then on top of that runs our controller VM, which has all of our intelligence in it. So all of the stuff that we do, all of the improvements we do, and all of the changes we make happen in that controller VM. This means that we're entirely software defined. Because of that, a simple upgrade means that performance gets better. It means that new features get added. It means that everything just runs better. So all of this stuff is here on the CVM. Each node has a controller VM on it, and the controller VMs connect to each other over a standard 10 gig network. By talking to each other, they're able to combine all of their local disks together into a distributed storage fabric, which gives you all of the benefits that you've come to expect from a regular storage array, but with the benefits of having the disks local, along with the distributed nature of this. So we'll talk a little bit more about why that matters when we get into the actual applications. And we'll show a little bit about some of the different ways that this can improve like the read and writes. We're also working on application and data mobility. Our goal is to be able to take these VMs and applications you have running on-prem and move them up to the cloud. I'm not going to sit here and tell you that's today. I'd be lying. We have the ability to back up VMs to the cloud today, Azure or AWS, as your choice may be, and then recover those snapshots later. And we're also looking at ways that we can start rehydrating those VMs up in the cloud and give you a single pane of glass to manage VMs cross clouds and cross infrastructure types. So that's where we are today with application mobility, because at the end of the day, we believe, and I'm sure that you all would agree, is that applications are what matter. VMs, infrastructure, LUNs, are just abstract concepts. What really matters is the application. That's what actually delivers business value, and that's what actually you're measured on. So our goal is to make it so that you can focus on that application, not focus on what's running underneath it. So one of the ways that we get there, this is super markety, but basically our goal is to simplify the infrastructure management as well. So we remove all of those different pieces and pull it down to a single GUI that does it all in one place. And one of the things that I really like about Nutanix is that we treat the GUI as a first-class citizen. It's not like an afterthought or something like, oh crap, we're 2 months from release, we really need to have a GUI. Nobody wants to do this from the command line. The GUI team actually has as much say in product development as anybody else at the company. So, and I'm biased, but I think it shows. So we've got a lot of things there. Luckily, this is the last of the marketing slides, so we'll just blow right through this. Prism gives you a bunch of ways to simplify your management. The ones that are really, really interesting, I think, are the capacity behavior trends and the capacity optimization. Without having to do complex configuration, you're able to automatically the system will determine how long your current resources will last, when you need to expand the cluster, and if you've got any VMs in the cluster that are either over-provisioned or haven't been turned on in a while. So you can recover some space that way. And it also gives you a what-if analysis. So you no longer have to guess or do a bunch of math to figure out hey, we need to add another 100 users. What is that going to do to my system? Or we just bought a company and 1,000 users are joining, or 1,000 SQL servers are getting added. What does that look like? Prism allows you to automatically calculate all that out. So those are just a general quick overview of what Nutanix does, and really the end of the marketing slides. So let's get started and talk about Nutanix with Hyper-V. As I said, we give you guys a choice of hypervisors, and Hyper-V is one of those. So if we take a look at how Nutanix and Hyper-V work together. So we have the CVMs. Remember that each host has a single CVM running on it. And these Hyper-V hosts all join a Windows failover cluster because the Windows failover cluster gives you the live migration, the HA, and all that fun jazz. And then the Nutanix CVMs also join a storage cluster. This storage cluster provides an SMB server down to the hosts. And I'll show in the next slide how we do some of the networking so that everybody's accessing their local disk, their local CVM, even though they think it's a single share. And we also provide a VSS agent and SMIS provider. Taking all these together, it means that you're able to do most of your management, if you're using Hyper-V, directly from SCVMM. You don't even need to use our interface if you don't want to. Our tagline a few months ago was invisible infrastructure, and that's really the goal, is making it so you can choose the tool that you want to use, not forcing you into one. So we do have some customers who use only SCVMM to do all of their Nutanix and VM management. So how do we do that? How do we trick the system into treating multiple different CVMs as a single SMB share? So we have, the default networking configuration has external interfaces, or the vSwitch external, and a vSwitch internal. The vSwitch internal doesn't have any connections to the upstream network, and that's where all of the SMB communication happens over. So the host will send all of its SMB over that local interface, and then if the CVM needs to talk to one of the other locations in the cluster, for example, to recover a piece of data or to write a replica, we'll use the external network to do that. So Hyper-V sees every host mounting the same SMB share with the same IP, but in reality, they're all using that internal switch. This means that every host doesn't have to jump over the network. It doesn't have to go to a single portal. It can just go to the local CVM for the requests. So let's take a look and see what that looks like in an actual read and write example. So in this case, we've got a guest VM over here that's got 3 pieces of data he's going to write. So he sends that down. Hyper-V sends it to the local CVM. And the local CVM then replicates it to another CVM in the cluster. And we spread these replicas out throughout the cluster. This way, if this host now dies, we don't have a data loss. So before we ever act the write, we make sure it's saved in 2 locations. So we do have to go over the network for that because of resiliency. However, the real advantage comes in when we do a read here. So now that guest VM needs to read that data he just wrote. We're able to read that directly from the local host. No need to go over the network. No need to go to anywhere else and give it to the guest VM. This means that the guest VM is able to get the advantages of a local SSD. In the most recent version of code, I think we're able to push 4 SSDs at line rate using our code. So at the end of the day, these reads are happening very, very fast. There's no extra latency from jumping over the network. There's no extra network between you and your data. But that raises another question. How do we handle live migration? Because at the end of the day, an HA event happens or a VM moves or you're doing maintenance, whatever. You're going to move the VM over to another node. So in that case, so say this VM moves over here. It's going to reference the local copy of the data we have and then the remote copies for the other 2. Once you read those data, we'll actually copy it over here and make it so that the RF copy is local. By doing this, we're able to, as the VMs move around, make sure the data follows it in an intelligent fashion, always giving you the best possible speeds. So we have a bunch of different solutions for a bunch of different use cases. If you asked us 4 years ago what we did, we would have told you VDI. However, at this point, more than half of our customers are running multiple workloads on us, and more than half of them are running business-critical apps on us as well, such as SQL or other business applications. So we've definitely expanded, and at this point, we're pretty confident that we work for just about any workload. So let's start talking about something interesting, private and hybrid clouds. So building off of what we have already in Hyper-V, we can see how the communication works, how we do reads and writes, and how the data moves around. Let's talk about what we can do with a Hyper-V in a private cloud scenario. So we do, using Azure Pack, we have a full RA for this. We're able to create the tenants using Azure Pack and build it off of the Nutanix platform. The real advantage of this is that now you get both benefits of the cloud. So if you put Azure Pack on a traditional infrastructure, it gives your users the ability to directly access the infrastructure, but the infrastructure can't grow like a cloud does. It can't grow as fast. It can't adapt to changes. So by doing this, you're able to grow the Nutanix environment, and you're able to use Azure Pack together. So we're Fast Track certified, and we make it real simple. We also took this one step farther. If you haven't even begun your cloud journey, or you're looking for a cloud-in-the-box kind of solution, we have CPS Standard, which is basically a way to automatically deploy. The box comes from the factory with Hyper-V, and it automatically deploys System Center Operations Manager, Virtual Machine Manager, and Windows Azure Pack, along with all these supported SQL databases required. So you're able to go from basically nothing to a full cloud fully automatically without having to configure anything. How many people here have tried installing SCVMM? It's not a lot of fun. So that's really the goal here. Is for Elastic-Night, I had to get an SCVM demo up, and even though I knew everything I was doing and knew that I had full control of the environment, it still took me 2 to 3 days to get all of the actual checkboxes finally met. So they can be complex things. So our goal here is to make it really simple to get that cloud deployment. So this will give you the full stack and give you the ability to start using private cloud stuff. And then using Windows Azure Pack, you can tie into the other Azure services, such as Azure Site Recovery and Azure Stack when it comes out, and then start using that all together in one unified bundle. And just as an example of this, one of our customers, Jabil, uses Nutanix and Hyper-V entirely, along with Windows Azure Pack, to do the cloud experience, or the cloud internal private cloud. I'm not going to read the slide word for word because that's pretty boring, but you guys can either read it quick or download the slides after because they'll be available. So this is something that we do see customers using, and it is a pretty powerful solution. So now we've got the cloud, we've got the Hyper-V. Let's talk about the actual applications. Why should you choose Nutanix for your business critical applications or for your Microsoft applications? And what are some of the best practices around there? So let's take a look first at why Microsoft apps or business critical apps on Nutanix. So the first main reason is performance and availability and scalability. Now that's a pretty loaded reason, mixes them all up together. But the main point we're trying to make there is that Nutanix is built in a highly scalable way, along with the ability to self-heal. So if you look at how the massive data centers are doing their infrastructure, you've got a big cluster. When hard drives fail, they don't immediately rush out and replace it. Instead, what happens is that they let the cluster fail to a smaller size and heal up, and then fail again and heal up. Once a week or so, they'll run around replacing all the bad drives, throwing in new drives, and let the cluster heal back up to full. This is really what we're trying to bring to every data center. The idea that a hard drive failure isn't an emergency. You can let the cluster handle it and replace it on your schedule. I've had customers tell me that they actually did not get the 4-hour service they got next business day because they didn't need it. And I've also seen robo customers, for example, using this because they might only be on site where the actual nodes are installed once a week or once a month. And so previously, if something failed, they had to rush out to that site and replace it. With self-healing, they're able to heal to a smaller size, let the system handle it, and then replace it on their schedule. The next reason is for security and compliance. We believe really strongly, very, very strongly in security at Nutanix. I'm not going to give the full pitch because security is one of those things that you either care about deeply or you don't care about at all. And so if you don't care about it, you're probably like, okay, yeah, shut up. But at the end of the day, security, no matter who you are, no matter what company you are, or how important it is to you, we believe it's really important to keep the system as secure as possible. So we have a full security development lifecycle where we're constantly analyzing, making sure that we're not introducing new threats or changing anything. We also have a full hardening guide and hardening report that's available in a machine-readable format. What that means for you is that if you've got compliance programs that you can use, you can feed this report into them, and it'll tell you if the system is compliant. The system will automatically also apply that for you if you set it up that way. So that not only will it immediately apply it, so you're able to shorten any of the hardening period down, it'll also audit the system and whatever schedule you define, saying, I want you to check every hour. So it'll go and see if anyone has moved away from that secure baseline and then move it back into that security baseline. Because at the end of the day, systems are only as secure when they leave the security team the first time. As soon as they're out in the wild, an administrator is going to open a port, going to enable SSH, FTP something, and unless you're going back and auditing, you'll never catch that. So our system will automatically do that if you enable it. And then we also have the ability to do common DR procedures, and we'll talk a little bit more about the different DR mechanisms later. And then finally, one of the reasons that one of the biggest reasons that customers end up going with us is cost. You end up with less complexity, which means that there's less time spent managing the infrastructure. We commissioned it, so vendor report, whatever. But one report that we have says that administrators spend 90% less time administrating a Nutanix system. What that basically means is that if you spend an hour a day today in managing your infrastructure, that goes to an hour a week. And that frees up IT teams to do more important things. Fewer silos. We no longer have a different silo for each different step in the infrastructure. It's all unified together. So you're able to reduce the cost there. And it also makes scaling much simpler by having it all reduced there, because there's no longer a question of, okay, well, if we add a disk tray, is our storage head going to be able to handle it? No, well, if we upgrade the storage head, will the SAN be able to handle it, or do we need to upgrade that too? And it ends up with this whole mess of questions. We make that much, much simpler. We're able to better utilize resources. So with Nutanix, since you're able to start small, minimum of 3 nodes to begin with, and then grow as you need, you don't have to do massive over-provisioning in the beginning. If you look at a traditional infrastructure where you've got a big storage array, maybe the smallest one you can buy is 80 terabytes. If you only need 20 in the beginning, that extra 60 is just sitting there not doing anything. Now maybe in 8 months you'll be using it, but it's better if you can buy it when you need it rather than being forced to over-provision in the beginning. Because that way, not only can you have a lower upfront cost, but you can also take advantage of things like Moore's Law. Because maybe in 8 months there's a new processor out. And so because you expanded the cluster then, you can take that efficiency is now passed on to you. And then finally, on-premise versus the cloud. We want to make sure that you can choose the right place to run your workload and that you're not forced into one or the other based on what it gives you. So what we mean by that is that if you look, there's some workloads that make absolute sense to throw in the cloud. There's no question in my mind that there's plenty of things you can own there. Especially things like new applications where you don't know what the demand is going to be, or something where it's a short period of time where you're going to have that utilization. Like NASA used the cloud to broadcast I believe a Mars webcast, and they knew that they were going to need it for a very short period of time, and after that they didn't need it at all. It's perfect for the cloud. But if you've got something you're running 24/7 that your business relies on, it might make more sense to run it on-prem where you can completely control what happens with that application, what the SLAs are, what protections you put on there, and where the data is stored. So we want to make sure you have that flexibility. I'm going to skip over these slides here because I already have a ton of material and not that much time, but you can read through them later. Basically, the idea is that if you're looking at on-prem versus Office 360, there's definitely benefits to both, and Nutanix can help bridge some of that gap as well. So that really brings us to our next point, which is talking about Microsoft Exchange. So with Microsoft Exchange, you can use a single platform to deploy all of your different roles. So we have many customers running Exchange on us. We've got some very large ones. I think there's one that's going in right now that's 80K mailboxes. We also have a bunch of people running much smaller Exchanges on us. That they're doing that either for data residency concerns or for that they need to do massive archives. So at the end of the day, we've got a lot of solutions across here. Using Nutanix, you're able to unify, use a single platform for all the different roles. You don't have to have different, like bare metal servers for different things. You're able to optimize the capacity because we have built-in things like dedupe, ECX, and compression, so you're able to store more mail in less space. The availability tools work in tandem. What we mean by that is that Nutanix has has RF2 by default, so we do two copies of data. Microsoft recommends if you're doing physical servers to have four copies of the data, 4 DAGs, or 3 if you're feeling lucky. With Nutanix, you're able to combine those two together. You can have two DAGs along with 2 copies on the Microsoft side along with 2 copies on the Nutanix side to get the total of 4 copies there. So instead of having to manage 4 servers, you're able to manage 2, which makes it much simpler, and these tools end up working in tandem. The other thing that's great is data locality for Nutanix. As I showed in that previous read example, is that we keep the data local. So as Exchange moves around, it's able to stay there, which gives you the same, the data stays with Exchange. And so that gives you similar performance as if you're doing bare metal Exchange. And then finally, match scale out with scale out. I'm going to dive into that a little bit more later, but basically the idea there is that Microsoft recommends a scale out approach for Exchange. Nutanix recommends a scale out approach for infrastructure. They work very, very well together. So we're hypervisor agnostic, and we're fully supported with Exchange on vSphere, Hyper-V, and AHV, which is our KVM variant. We have ESRPs for Windows Server and AHV. So, apologize, the quote there doesn't make much sense without the previous slide that I pulled out of this presentation. But basically, the idea here is that virtualization is a common solution to the scalability problem. As you continue to grow your Exchange environment, virtualization allows you to do that much easier and allows you to manage a much larger environment without adding more silos. So it's definitely the way to go. So if we take a look at Microsoft Exchange on Nutanix, we've got a primary copy and a secondary copy here on the primary site. We can have up to 10K mailboxes per node. That's what our ESRP shows, which is about the maximum recommended size by Microsoft. We have, you break out the DB and the logs, and we also have the ability to present iSCSI volumes directly up into Windows, so you can use them directly if you want to do it that way. You're then able to replicate this to a DR site using either our native replication or Microsoft technologies, and then you can also copy that over to a mutable copy if you need to do archival or you want to do testing or what have you. So, don't want to go back. This is just a short example of what a system could look like and what an infrastructure could look like. And as we mentioned there, we're able to get 30K mailboxes. I'm sorry, I know that I'm not supposed to point and then immediately take it off because then it's impossible to see. But we're able to get 30K mailboxes on 3 nodes. So you're able to get very, very dense, very, very powerful Exchange servers using this. So let's, talking a little bit more about the design methodology here, is that, going with Microsoft's recommendations is that they don't recommend you taking a single Exchange server over 24 cores or 96 gigs of RAM. So that's about the maximum there. So using the one of our platforms, you're able to get a ton of RAM, a ton of physical cores, and a bunch of other stuff in there in just 2 RU. So what that means is that you end up with very beefy servers that can only fit small Exchange because you can't have any more than that. So instead, what you can do is you can set it up so that you've got one DAG with one set of Exchange servers, set up with another DAG with its second set of Exchange servers, and then have another set here with your management VMs. So you're able to keep all of these different applications on the same platform, and you're able to run multiple things together. There's one customer that I know of that's running Exchange alongside of XenApp and Splunk all in the same infrastructure. So they're able to consolidate all this down and keep it in a single unified infrastructure, no additional silos, and make it real easy to manage. So the other thing to note about Nutanix is that you can mix and match node types. So a cluster might have some of these 8150s, because 8150s are really designed for high-performance databases. And you can have those mixed with some of the other more workhorse nodes or the more mid-range nodes so that you can have that full mix of performance in your system. So that's Exchange in a nutshell. You want to match scale out with scale out. You want to make sure that you're setting up the right availability groups and using the right DAGs, and that you set up a right DR plan. So from there, let's talk about some database servers. Exchange is a database, but it's a unique one because most databases don't have the same profile as Exchange. So let's talk about SQL in particular here. So some principles of databases are that databases are an extension of storage. And it seems pretty straightforward, but it's important to level set with that, is that at the end of the day, the database's main goal is to provide you better access to storage, in an organized way. So if your storage isn't up to the task, you're going to be boned. And then the other point of that, as a corollary, is that performance is more than just the underlying storage devices. If you don't design your database well, it doesn't matter how fast you put the storage layer underneath it, you're going to have problems. And then finally, size for performance before capacity. There's a really great quote that's something along, I believe it's, the sweetness of a low price is forgotten long before the pain of bad sizing is. Basically the idea there is that you want to make sure that your database will perform before you just simply make sure you have enough space. If you're not able to get information out of it, the database is effectively useless. So some additional principles, because we're an entirely virtualized company, we believe strongly in virtualizing without compromise, but make sure you don't put any compromises in there. So you want to make sure that you get all the benefits of virtualization without losing anything that you might get from bare metal. You want to keep it standardized and simple. If you've got 100 different databases and 100 different database configs or infrastructures, good luck. And then finally, all flash for the most demanding workloads. In today's world, we're at the point where flash is fairly comparable to hybrid or HDD systems in many cases. And so at this point, all flash is becoming the norm rather than the exception. But I left that here because it's important to remember that, is that some databases that are not as demanding might get a little bit of savings from doing hybrid. On the other hand, if you've got a database that is super important and is going to be hitting the entire data set the entire time, all flash is the way to go. So when we're sizing on Nutanix, how do you choose the right platform? Nutanix has a sizer tool that our partners and sales teams use to help size these out, but if you're just looking and you're trying to figure this out on your own, what are some things to look at? So Nutanix has two different kinds of models. There's first hybrid models, and the other is all flash models. With hybrid models, we have a mix of SSD and HDD. So the first thing you want to do is make sure that the SSD is big enough for your working set size. The data that you're constantly churning, that you're touching, or however big that is, you want to make sure that fits in the SSD. You can usually find that information from backups. They usually have the rate of change in there. And then HDDs are good for cold storage. So because you're able to mix and match different kinds of nodes in Nutanix, you're able to use storage-only nodes to reduce the DB processor licensing costs. So since most databases are priced or licensed on a per processor level, using storage-only nodes where they don't actually run any of the database, they can't run the database, they only provide storage, you're able to grow out the archive space or grow out the other sizes. And in the next release, you'll be able to add in all flash nodes to do the same thing. You're able to grow that out without actually increasing your costs, making it really easy to do audits. And large databases love compute memory and SSD. I mean, at the end of the day, that's almost a no-brainer. If it's a demanding database, it likes resources. So there's a couple of the nodes there, depending on if you want Delanova or NX. And then another important thing, and something that we believe strongly at Nutanix, is that data reduction techniques are amazing, but there's no guarantee of a particular reduction you're going to get. When we're doing sizing, we usually assume that you're not going to get any savings. But at the same time, most databases, because it's usually text, you get pretty good savings on. And so you can use inline compression on Nutanix to see those savings. And you can use it in combination with the database level, because there's, when we're compressing, we're able to compress more than just what the database can. So your mileage will vary. If anyone's telling you that their product will give you a 10-to-1 reduction, they're doing something, because no one can, until you actually have your workload, you cannot see, you will not know for certain how much data reduction you'll get. So we have the ability to use all of the dedupe compression and ECX, and we definitely recommend using them, but definitely keep that in mind, which is one of the reasons to start small and grow as you need. Because if you start small, you can see how compressible your data actually is, or how dedupable, and then size based off of that. The other thing never mind. I was going to say something else there, but then I forgot, so never mind. And then some other best practices is that your max memory should be less than total memory. You want to make sure that you've got the right degree of parallelism so that you're able to do the most amount of processing. You want to separate out the drives for the different components of the database. By separating these out, you're able to ensure that each one gets their own performance, their own handles and their own, basically that you're not overlapping resources. With Nutanix especially, we do everything on a vdisk basis. So what I mean by that is that every vdisk that you create is a single-threaded process. So with Nutanix, if you have one disk that's doing everything, well, that's only a single-threaded process. On the other hand, if you do 4 disks across that, not only are you able to use more resources on the virtual SCSI controller, you're able to get more threads from Nutanix on it. So it's best to separate these things out. Once security policies, you're able to lock it down a little bit more. And something we're going to dive into a little bit more on these next couple slides is, how do you balance the size of the SQL VMs and the number of databases per VM? So how do you, or put another way, the scale up versus the scale out conundrum. And then just as a general advantage, use trace flags with care because they can really hammer the system. So let's take a look at the scale up versus scale out conundrum. So you can see here we've got 2 different runs here. So in this first run, we're doing a scale up where you've put 4 VMs. I'm sorry, we're doing a scale out. In this case, we're doing a scale up. So in this case, we put 4 VMs on a host, each with 2 vCPUs. And over here, we put a single VM with 8 vCPUs. As you can see, the performance between them overall isn't really all that different. So what this means is that you can easily scale out a SQL server compared to just scaling it up. You don't need to make a monster VM or a behemoth in order to get the best performance. And this once again goes back to what Nutanix recommends. We're a scale-out system. If you want a single monster VM, we probably aren't the right place for that. But if you can scale out the system, then that fits with our architecture and our design, so it works really well together. To take a look at this another way is that we've got over here the transaction per second per node, and these are the same graph shown a different way. As you can see, this is showing the scale out. So we've got 3 nodes here that are each doing 1900. As we add another 3 nodes, they continue to add that 1900 on Nutanix. So there's not a point with Nutanix, since we're doing that in a single-threaded fashion, as I mentioned, each individual VM or each individual disk gets the full performance. There's not, as you see here, they're not like chewing up extra resources that are no longer available. Or put another way, these guys get this performance, and as you add more nodes, they continue to get that same performance. So as you continue to add nodes, the same performance happens again and again and again and again, which makes scale out really, really easy, or really, really powerful, I should say. And across the entire data set here, you see that the transaction time remains stable. So even though we've now more than doubled the amount of SQL VMs running, we haven't changed the time it takes or the amount of transaction per second it's running. So next, talking about reducing database licensing costs. As I mentioned, or as you probably are familiar, most databases are licensed on a per core basis. So using Nutanix, you're able to isolate that down to or not even just Nutanix, no matter what you choose, you want to isolate the amount of nodes that the database can run on to a limited number of hosts, just because that way you're not paying for something you're not using. You want to optimize cores per socket and clock speed. If you're getting charged per core, maybe you want to go for a higher clock speed, lower core count on the node versus many more cores at a lower clock speed. And you want to, using Nutanix, you've got configure to order options for all platforms that allow you to configure it as all flash or whatever mix you're looking for. So you can use that to make a really, really powerful node that has tons of flash and really powerful processors with low core count and limit the database to those nodes. We also have what we're calling Acropolis block services, which is the ability to take carve out an iSCSI, basically a LUN, but we don't really call it that because we hate LUNs. But it's the same idea. You're able to carve out a little space, a vDisk, and present that out to a bare metal host. And we see that being used in cases where Like, for example, Oracle. Some people like keeping Oracle bare metal because otherwise the licensing costs really balloon fast. So if you keep that bare metal and then consume storage on Nutanix, you get all the benefits of Nutanix on the bare metal server. Granted, you miss the data locality because you are jumping over a network there, but you're still able to get the scale out performance. And using these combinations, it's easy to be audit ready. If you've limited down your cluster to, say, 2 nodes, that one for the primary and one for HA, and you've got another mix of storage-only nodes or all-flash nodes in the cluster, it's really easy to be ready for audits when they come, because you can show, the VMs only existed on these 2 hosts. So you're able to combine them in whatever fashion. Another thing that people really like with Nutanix, and that we see a lot of people using, is that we do everything in a VM-centric approach, which means that you're able to do really efficient dev test environments. So we've got this production VM running over here, and we're going to make clones of that, since we can, on a per VM level, say clone. And these are storage level clones. They're not hypervisor level clones or checkpoints or any of that. This is a true storage clone based on the metadata update and all that fun jazz. So what that means is that you don't have a performance degradation here on the main VM when you make these clones, and that these clones are completely independent from the production VM once you've done it. Using that, you're able to quickly spin up VMs for QA testing. I was actually just talking to a customer here yesterday who was looking at ways to do this so that they've got their production running, they want to clone it over to another VM so they can diagnose bugs on the system, without actually affecting production. So because we do everything on a per VM level, you're able to do that really quickly and efficiently. And this works with SQL, Oracle, and just about any other workload. And because we're software only, these kind of operations are constantly getting better. If we take a look here, this is our 4.1.2 code train. This is how long it took to do 12 clones of a 500 gigabyte SQL VM on VMware vSphere, but we'll say that quietly since it's Ignite. But on the other hand, so that's our 4.1 train. 4.6, which was 2 major releases later, we moved that down to about a third of the time. So this just happened with a software update. There wasn't any hardware that needed to be updated, any reconfig that needed to happen. We just made the entire process go faster and more efficiently. This ties back into that, the continuous innovation that I mentioned on that first slide there, is that you're able to, with an upgrade, or without even affecting the VMs, get new features, get new performance, get new capabilities without having to take an outage, without even noticing it in many cases. So that's a bit on SQL, a bit on Exchange, a bit on just a couple of tastes here and there. And if you've got one of those workloads that you're looking to run, definitely come talk to us down in the booth. We have some good material and some really good experts down there we can talk to that about. The next thing I want to talk about is data protection and disaster recovery, which is a critical part of any enterprise plan. I mean, you can make the most efficient system possible, but if it can't handle an outage, or it can't recover from an outage, you're going to have serious problems. And that's actually something that we recommend you look at when you're comparing a lot of these new systems and the new hyperconverged systems, is how they perform under failure. How do they actually handle site failures? How do they handle node failures? Because many of the products in the space work fantastically in perfect conditions, but they crumble under a failure. And that's really not the time that you want to find that out. In a failure scenario, you're already running down some. You're already hurting. And for your storage system or your infrastructure to fail you at that point because the design wasn't good, then you're not in a good place there. So anyway, let's talk about the different ways that Nutanix protects your data and the different options you have for it. So on the lowest level is hardware failure. So hardware fails. If somebody's come up with a invincible piece of hardware, please let me know, because I'd like to go into business with that, make a lot of money. But at the end of the day, drives fail, DIMMs fail, CPUs fail, motherboards fail, all of that. Nutanix will automatically self-heal from any of these failures. We will take the system and move back into a redundant state. Because we spread the data out across the entire cluster and not mirrored pairs or anything like that, the larger your cluster gets, the faster the self-healing goes, because every node and every disk is able to participate in the rebuild. And of course, we have full redundancy of key components. You can change between RF2, which is you can tolerate one failure, and RF3, which you tolerate 2 failures on the fly. You tolerate 2 failures before self-healing happens. So you're able to choose that and customize it per workload. Like for example, maybe you've got you care deeply about your SQL database, so you turn on RF3, but you don't really care about your VDI VMs because you can just recreate those. So you set those to RF2 to save space and give them a little extra performance. Next up is a node level. So we're fully resilient on the node level as well, and we have non-disruptive upgrades across the entire stack. So be it do you need to upgrade your storage firmware, your hypervisor, your actual BIOS, BMC firmware. We handle all of those in the GUI in a non-disruptive fashion. And the one that's most impressive is the storage software is able to upgrade without even moving the VMs. Everything else the VMs need to move, but we handle that for you. The next level is the actual data protection. This is where the tunable redundancy comes into, where you can choose 2 copies or 3 copies of the data. And we also have erasure coding, which is a way to, for simplicity, I'll call it network RAID. And so instead of doing a hardware RAID where you're in the same node, we take multiple copies, spread out across nodes, and reduce them down. So you're able to save space that way. And then something that's really important is transparent, consistent checks. So we are always storing checksums in Nutanix. And not everyone does that, so it's something we believe in. And that's actually how we detect things like hardware failure. Because if we when we're reading from a disk, if we're getting bad checksums from that disk, we'll be like, okay, that disk is failing, mark it offline, and automatically start recovering the data. So because of that, we're able to detect disk failure even before something like Smart kicks off. On an app or VM level, we have the VM-centric protection, which is as I was saying, you can do snapshots on a VM level. We can also configure what we call protection domains, which are basically a collection of VMs that are snapshotted on the same schedule. And using that, you can either keep local snapshots or replicate them to another site, be that another Nutanix cluster or the cloud. HA and DRS, everyone knows those. Or, I'm sorry, we should call it HA and Pro Resource Optimization. And then ecosystem integration, we have a lot of integration with backup partners. If you're using Hyper-V, we work with just about anything that works on Microsoft. We also have special integration with some vendors like Commvault, where they can use our snapshots directly, which makes it even better. And then finally, the real interesting stuff comes down to the site level. We're able to replicate from one Nutanix cluster to another, or from one Nutanix cluster to multiple different places. We're also able to do metro availability or sync replication. In that case, you have absolutely you have a RPO of 0. We do not acknowledge a data write until it's been written to both sites. So in this case, if a site goes down, you can immediately start running on the other site without any sort of downtime. So let's take a look at where all these different pieces fit in. We have broken into two categories here, minor incidents and major incidents. A minor incident is something like accidentally deleted a VM, or a file was deleted, or anything like that, where it doesn't actually affect the cluster stability, but you really need to recover that data protection effectively. In that case, we've got time stream, which is local snapshots, but we decided to give it a fancy name because it sounds so much cooler that way. Or Cloud Connect, which is the ability to send the snapshots up to the cloud. Major incidents, which is where this cluster went down, this site went down, we need to turn on the VM somewhere else. We have the remote replication and the metro availability. So I'm not going to read through all the different parts of the chart here, but the idea is that you've got to take a look at your workload, what kind of time you're willing to accept being down, and what kind of RPO you want, and then choose the right solution based on that. But we have a wide variety here. And so let's take a look at how the replication might work. So in this case, we have 3 protection domains here at location 1, replicating to 3 and 2. And 2 and 3 are replicating back and forth to each other. As you can see here, we can have replications being sent to many different sites. We don't need to be sending replications back to the main site. We can pick and choose where we want to go based on that. I was working with a customer recently. Actually, I'll talk about that customer in a moment because the next slide is sync rep. So you're able to do this on using application consistent snapshots or crash consistent snapshots as you want. And you can also use our API to runbook this or whatever runbook tools you'd like to use today. And each one of these different protection domains is fully customizable on the retention policy and the replication policy. So the other piece is synchronous replication. So this is where you can take two Nutanix clusters and basically tie them together, tie a container together, so that that any data written on one is written on the other. And in Nutanix terminology, since I didn't really talk about that, a container is basically the same thing as a SMB share. So each container that you configure in Nutanix would show up as an SMB share to SCVMM or to Hyper-V. So in this case, we have an active container over here, and every write that's written here is synchronously replicated over to the standby container. And we have it happening in the reverse as well. So because of this, if one of the sites goes down, you haven't lost any data because all of the data was written to two completely physically different sites before it was acknowledged. The other important thing to note about this is that each one of these clusters is independent. This is not like a stretch cluster where we have an RF1 copy here and an RF1 copy over there. These are two completely independent clusters that are just synchronizing the writes across these containers. So you end up with two copies over here and two copies over there. So you end up fully protected against any levels of failure. And you can combine all of these different types together. I was talking, I helped out a customer recently who he has got 3 sites. At each site, he put in 2 all-flash clusters. Those all-flash clusters were metroed together, so they were in a single metro cluster to each other. And then those clusters also sent a snapshot to each one of the other 2 sites. So in this case, they were able to handle if a row went down or one of their data centers goes down in the same building or same site, they're able to recover at the other one. If both of those go down, they're able to recover on the remote site. And because of that, they were able to really fine-tune exactly what they wanted for their protection. And then finally is the Nutanix Cloud Connect. This is basically the ability to take snapshots down here and send it up to wherever you want. I apologize once again for the AWS reference here. That should be Azure. Just mentally replace it. But at the end of the day, we connect to AWS or Azure. When you configure Cloud Connect, we'll automatically set up one of our controller VMs running in the cloud, and then we'll send snapshots up to that. From there, you can either pull them back down later on, or you can use that as a backup tool. So eventually, we hope to be able to do things like full migration to the cloud, but we're not there yet. And we also, all of these different replications are done in a WAN optimized way. So we have the ability to do things like limit bandwidth utilization, to compress on wire, to if you have dedupe on both sides, it's able to only send the changed blocks. It doesn't send over replica blocks and all that fun jazz. So there's a lot of power here that you can do, and a lot of different ways that you can combine this to meet your needs. And at the end of the day, we've had a ton of different customers. We've got a lot of pretty broad adoption across many different industries here. And we've got, if you go to www.nutanix.com/customers, you can take a look at all of our different case studies and logos and stuff. At the end of the day, I can sit up here and talk for hours on end on, oh, Nutanix is great, but I'm just a marketing guy talking. The true proof is customer experience, and what they're saying about us. So definitely recommend checking that out. This is our #1 slide that we love showing all over the place because we have the #1 companies in many different industries running on Nutanix, either in big or small ways. So there's definitely a lot to do there. So now that we've talked about all that, I want to open the floor to some questions. Does anyone have any questions about any of the things we talked about there? Anything else about Nutanix? Anything that you wish that we had covered? Yes, so the question was, is the minimum requirement 3 nodes? Yes, it is. So we require a minimum of 3 nodes. We can get pretty small on those initial nodes, depending on what your exact need is. But the reason that we require 3 nodes is that since we distribute everything, we need at least 2 nodes alive at all times for quorum. So the question was, is there different platforms and different hardware available? Yes. So Nutanix sells Supermicro servers, but that's not the only option. We also sell, we have an OEM partnership with Dell, and they've got their XC series. Lenovo has their HX series, which are their servers running our software. We also have a meet in the field option with Cisco UCS. So if you can buy a particular UCS config and then run our software on top of it. So you've got options. The only limitation there between vendors is that you can't have multiple vendors in the same cluster. So you can't have a single cluster that's half Nutanix and half Dell. And that's really just more for supportability reasons. You can have those clusters replicating to each other, or you can have them all managed by the single Prism Central instance, which will manage all of your clusters together. Yeah. So we can give you, so the question was if you prefer Cisco UCS, can you buy it right from Nutanix? No, but we can give you the BOM that you purchase that from Cisco, and then we can, there's a whole process for that. For the Cisco one's a little bit more complex just because that's a meet in the field versus the XC and the HX, which are an OEM. Because with XC and HX, you write one PO to Dell or Lenovo, and if you buy NX, you write one PO to Nutanix. With the Cisco, you'd write one to Cisco and one to Nutanix. So, but we have, we can guide you through all of those processes and make sure you get the config you want. Mm-hmm.
So, in terms of performance, if I don't think, can I have the advantage or benefit of parallel processing when I retrieve the data for the system?
So the question was, we can replicate to multiple nodes. Can we have the benefit of parallel access of the data, right? So that the idea there is basically you're saying that can we pull the replica copy? So we have two copies of the data at once. The short answer is no. So we can't, there's no way for the system for you to say, hey, go get the second copy of the data. But the system will automatically, when you're pulling up a data from the cold tier, it will automatically look at both replicas and choose the best one. But there isn't a way, like for example, with a big data application like Splunk, you can have multiple copies of the search data, and that you get faster searches. That's not possible with Nutanix today.
So, or is something like a replication of data? I can strip the data, right? For example, I am to strip the data for, let's say, talking of the database system.
Mm-hmm.
To go with even more granular, like table level, like a massive table of, let's say, 700 gig.
Yeah.
Strip to different replication. Is there any way that I can strip the tables, objects, system, anything like that?
So I'm trying to make sure that I understand the question. So could you, yeah, I'm sorry. So you're basically asking, like, if you've got a very large data set, is it possible to retrieve just like smaller pieces of it?
Yes.
Okay.
I strip the data in multiple nodes or platforms.
Yeah. So, so you're saying you want to have multiple, you've got multiple nodes across that are all accessing the same data set.
Yeah.
Okay. So the short answer on that is that today, when you open up a file handle to a disk like that, it's owned by a single CVM. So if you've got multiple guys across it accessing the same bit of data, you can't read and write from that same disk across multiple nodes. So there's not that parallelism. We do have some things in there for if you're reading across multiple nodes. So if you're only reading data from the same massive data set, we are able to detect that, and we will copy that data set to every node so that every node can get a copy of it local rather than having to go to a single place in the cluster, which works really well with things like VDI golden images.
Do we know what the replica set is? I mean, let's say you actually have data across.
Mm-hmm.
And then also you actually replicate in these different nodes, right? Because there's obviously there's storage utilization across the nodes that way.
Yeah.
Is there a sort of how you define the replica set and
Yeah.
the capacity allocation for that?
So the question is, is there a way to define where the replicas are going and see where they're stored? So we do all of our replication on a 1 meg level. So you will write 1 meg locally and then choose a random node for the other meg, and then we'll continue that for every single meg in the system. So we do a pretty good job of doing a random distribution across the rest of the cluster. So it's a pretty safe bet to say that you've got one, if you've got a 10 node cluster, you've got one copy locally and then 1/9 on all the other nodes, right? And the system's also constantly moving data around. We have a process that runs in the back end called Curator. which will do disk balancing across the cluster to make sure that all the disks are proper. There's no one disk overutilized or anything like that. And it's also doing spot checks. So we'll read the data and rewrite it to protect against bit rot and that kind of thing. So there's no, if you've got a particular piece of data that you're interested in seeing where it's stored, we can find that out through some backdoors. But there's no visualization showing that this data is here and there in the GUI today.
What I'm asking is actually the capacity utilization. Now,
Okay.
we have the production data set of, let's say, 10 terabytes.
Mm-hmm.
And what would be the replica?
So yeah, okay, so you're saying in the same cluster or to another cluster?
I mean, across the whole, I guess, cluster.
Okay, so the question here is, okay, if you've got 10 terabytes of production data, how much will the replica take up? 10 terabytes. We do RF2. If you by default we do RF2. You can set that to RF3 as well, so you get that third copy. We do have erasure coding, which you can turn on if the workload is mostly write once, read many, or worm workloads. You can take that replica copy and erasure code it down to reduce that number of space. And with erasure coding, the maximum, so if say that entire 10 terabytes was erasure coded, instead of taking up 10 terabytes of replica space, it would take up 250 gig. I'm sorry, 2.5 tera. So, but it's, there's capacity optimization and all that. But just basic is RF2 second copy, full copy. Okay. What other questions do people have? Anything? Well, awesome. Thank you guys for coming. Hope it was a useful session. There's a ton of stuff that Microsoft wanted me to show you. So if you want to plan your career path, though if you're here, I feel like you probably have a career path figured out. But if not, you can figure it out here. You can join the tech community, in case you didn't know that Microsoft has a tech community. Channel 9 has recordings about the event, and you can download trials from Microsoft. You can also win a Spark After Dark, apparently. If you know what that is, let me know, because I've got no idea what it's talking about. But you can you might be able to win if you complete your session evaluation here. And collect your wristbands, because you need those, I think. Anyway, thanks.